Thank you for coming to probably the most exciting session for today. I'm going to take my head off for now because I'm not going to perform any rabbit tricks, but hopefully I will still introduce you to some interesting and useful tricks with drivers and DevCenter. Our agenda for today is pretty easy. You already heard the trend of simplifying things. We're working with Cassandra, and what the team here is building is focused on simplifying developer life. And the second part of the talk will be about the DataStax drivers and the core principles. And last but not least, we'll shortly introduce DevCenter, which is a new piece of tool that we are extremely excited about. So, for a long time, if you are in the business of software development, we heard this, use the right tool for the job. And I think us as professionals should extend this question to use the best tool for the job. And what does it mean to us when creating tools for developers? What does it mean to create the best tool? What does it mean to create the simplest tool? So basically what we have in mind when creating these developer tools is to simplify choices. We have too many choices to make. They are rather complicated. We should focus our choices on the most important aspects of our application and not spend a lot of time on picking every library and changing libraries and so on and so forth. We also mean by creating the best tools, the tools that provide you access to best practices in building distributed application, in building modern application. So basically having an API that can accommodate different scenarios for your application, giving you flexibility to build these applications. And last but not least, providing all this in a friendly and familiar and integrated experience for the developers. So one way or another, I'm like, even if your company is not using any agile methodologies, our development experience is based on these 4 steps. Learn and experiment, or then implement, then test, then integrate, rinse, repeat. And so the team from DataStax is trying to create tools that address all these steps, and they provide you an integrated experience. And with that, I hand it over to my colleague, Michaël, that will talk about the drivers.
Thank you, Alex. So yeah, let's have a quick overview about all these new CQL drivers that DataStax has started to create over the past year now. But first of all, I'd like to recall you one of the biggest addition to the Cassandra world, to the Cassandra database in this process of simplification and simplifying the interface that you're working with daily. It's definitely to us CQL. CQL was definitely the step 1 in order to make things easier. Probably those guys that are here that are still working or that have worked in the past with the Swift interface definitely understand what I'm talking about. So CQL, I think probably most of you guys were either at the keynote this morning or at the State of CQL session by Sylvain earlier this morning as well. It's a query language, SQL-ish. It's schema-full, it's no more schema-less, so you structure cleanly all your data, and it comes together with a brand new protocol with what we call the CQL native protocol that has been introduced with Cassandra 1.2. And this protocol comes as a replacement for Swift. It's not meant to push Swift away from Cassandra. Swift will remain as a supported interface for very long, but this protocol is what we needed to continue to move forward with Cassandra and as a mature database. So it supports a lot of features, and let's actually have an overview of all of them through the client that we offer for this protocol. So that's, with all the drivers that we've released, there's some things that we wanted to do. We wanted to offer a consistent interface across all the language, as well, of course, as across all the tools, either CQL-SH or next you will see with DevCenter, so that developers can have a consistent reference, a consistent language. And for the driver, we wanted to have exactly the same, that is a constant set of features. So the Java driver is based on an asynchronous interface, but that's also the case of all the other drivers that DataStax has developed or is developing right now or will develop next. We support prepare statement, we support failover, load balancing, and different kind of with different kind of way to finely tune the way you do your load balancing and your failover. And this way of tuning things will come with you will get the same semantic across all the language. So that's very important. You can invest in with one application in one language and somewhat find someone be able to reuse all your investment in other languages. Investment and knowledge as well. So what's actually so cool and so exciting about this new protocol? It's not just about the fact that we move away from Swift with it. Swift, after all, was an RPC framework. It wasn't meant to be used as an interface for a database. There were some limitations, and this is probably one of the most interesting limitations, and actually of the new features that we introduce with this protocol. That's request pipelining. Request pipelining, as you can see on this diagram, is simply about the fact that the client doesn't wait anymore for the response to come before sending the next request. So whenever the answer, the response will come back to him, it will just dispatch it to the thread, to the client thread that is waiting for the answer, following a stream ID, following a kind of dispatching ID that is attached with every request. So in other words, what we do is simply that we multiplex a bunch of pending requests on top of connection. And that was very important for us to support very large cluster where the amount of connection created on Cassandra nodes was starting to be a bit critical. Another features that come with this protocol is notifications. So I want to make it clear here, we are absolutely not talking about notification for changes in your data. We are talking only about purely technical notification for events coming from Cassandra, events happening in either the topology of the cluster, the schema that you use in your cluster, or whenever you add a node, you remove a node, a notification will be sent to the client. So the client doesn't have to poll the cluster all the time to get all this information, and that dramatically simplifies their design. So I mentioned earlier that it's all based on an asynchronous architecture, and that's actually the case. So typically, of course, there will be some difference from the implementation from one language to from one driver for one language to another, like from the Java driver to the C# drivers. Java driver is leveraging native, which is a very popular network framework, which I strongly advise you to look at if you're not familiar with it. It's pretty cool, actually. So here, the kind of asynchronous architectures that we've got is that you will have a bunch of client threads, you know, that can typically be your HTTP, the thread for each of your HTTP requests. And they will talk with a driver, which will be a singleton. And this driver will just be responsible to dispatch your request to the appropriate node according to the load balancing policy that you selected. And for each of these nodes, we will maintain a pool of connections. So eventually, you will end up with a workflow a bit like this. There is a client thread, communicate with the driver, push a request, either read or write. This request is routed through the load balancing policy to the appropriate node. The appropriate connection in the connection pool is selected as well, depending on how much pending connection we add on each of the, how much pending requests we add on each of the connections. And whenever the response comes back, it will be dispatched to the client thread that was waiting for it. So in practice, because that's a nice architecture diagram, but let's talk about some code. And I will use the Java driver for all this presentation. It's definitely not the only one. As a reminder, we've got a Java driver, we've got a C# driver, which are both final and production ready. We've got a Python driver that is being finalized right now, and we're working to integrate to support much more language in the future. But well, Java is still the most popular language among the Cassandra users, so that's probably the good choice. So here, and that's the beauty of these new APIs that we propose to use, that probably I don't need to comment it a lot for you to understand what's going on here. Maybe the points that are worthwhile to comment is that we provide several contact points. You will typically want to provide several contact points so that you ensure that the bootstrap of your application, of your server application, will be robust if one of your nodes is down, or simply down for maintenance, or temporarily unavailable or unavailable forever. The driver will then auto-discover all the nodes of your cluster and will use all of them in its load balancing policy. So then you see you can push a write request, and things are very similar in some way to the JDBC piece of APIs that you were used to. So when you want to perform a read, it's not much more complicated. We've tried our best to modernize in some way the JDBC interface, as we provide you a result set that is directly iterable, so you can put it in a for each loop, which is much more convenient in a Java application. So probably no need to spend more time on this. Actually, it's fairly basic. That's probably where things get much more interesting, especially with Cassandra, because we know that Cassandra is, by design, very appropriate for very large-scale applications. And in large-scale environments, you very often end up pushing many requests. Most of the time, you want them in parallel in order to shrink as much as possible the latency of your application. So that's where it will be very interesting for you, these features. Basically, you will be able to execute async to get a feature on your result set, and with that, you will simply be able, from a single thread, to push a bunch of requests in parallel, and then to simply wait on all of these features to get the result. If you're not familiar with the future architecture of Java, I strongly advise you to have a look at it. It's pretty nicely designed. But actually, we also provide you another way to query asynchronously Cassandra here. It's simply using the fact that the features that we send back to you are implementing a listenable feature from Google Guava. So first of all, that means that you can leverage all the cool tools provided by Guava that are getting much more standard nowadays. And that also means that you can add a listener on your feature so that in some case, you might want to use some callbacks in order to simply trigger a new request whenever you receive some answers. It might be, for instance, if you send a query for some to get some IDs and you want them to get some data for all of these IDs, you can simply trigger the second query or the set of queries in the callback of the first one. And all that, of course, without having to generate and monitor and manipulate some extra threads, which simplify your code. Just to talk about some alternative way to manipulate your to send some statements, to push some statements to Cassandra. We support prepare statement. Obviously, I think all of you in this room should be familiar with it. We've got, because we look like SQL, we've got the same issues as SQL, and we solved these issues the same way, which was a good way. So using prepare statement that basically allow you, if you prepare it up front, it's not shown here, but if you will have a prepare method in your session, you just push a statement with some question mark, with some bind mark, and then you just have to set your parameters. The interesting thing is that you will manipulate a prepare statement object which will be thread safe and which you can prepare once at the beginning of as a startup of your application, and then you can share it among all your threads and set all the setting on the bound statement, which is the stateful object that you manipulate for prepare statements. The last piece of APIs that I want to mention here is that we also in the Java driver provide you a query builder. In some case it can be useful. The very typical use case that can be mentioned about that is when you need to generate some queries dynamically. It can be for an advanced form, for instance, where the user will add a bunch of criteria, and your query will actually depend on the criteria that has been provided. But it can also be used to create your queries for your prepare statement if you don't want to rely on some long strings. Yeah, you should probably always consider using prepare statement if you're doing some queries that are reused all the time in your application, actually. Some piece of architecture. I've mentioned some load balancing and failover. That's the workflow diagram that we use to make it work. So basically, you can see here that the client will send a query. It will be pushed to the load balancing policy. The load balancing policy is fed by some else monitors, some monitors that we've got on each of the hosts of the Cassandra nodes. It will be fed by the notifications that we receive from Cassandra about some new nodes that are added or removed, and as well by the possible reconnections that we were able to have on some nodes that failed previously. So once the load balancing policy could figure out which node is the appropriate one for this request, we will send the request obviously to this node. When the answer comes back, you will possibly have a retry policy. That's something you can configure. I will not detail it a lot here, but that's some options that you've got in order to decide how to handle some unavailability error or some timeout error or whatever. and then it will just be pushed to a dispatcher that will decide, that will just dispatch it to the client thread that is waiting for this result. The load balancing actually, by default, is just a fairly simple round-robin policy. I don't really have to detail that. Just a fair load balancing policy. And interestingly, we also provide you a round-robin DataStax aware load balancing policy that will actually allow you to push all your requests to your local nodes, and only if all of your local nodes are unavailable, the driver will then consider to push them to the remote node, which is the very typical kind of configuration most of people want with their multi-data center setup. But obviously, you can tune all that, or even maybe re-implement your own load balancing policy. The last point of architecture about this load balancing strategy is that you can actually make it token aware, and that's very interesting because that means that you can ensure that the driver will push the request to the node, to a coordinator node that actually own a replica of the request you currently consider. And obviously, the result is that you will shrink slightly the latency of your request, which is often something you're interested in. Just an API detail, the load balancing policy is something that you consider, that you configure at startup in your when you configure your cluster. So all of the things that I've presented so far are all the features that you can find in the driver 1.0 in Java, in C#, in Python. But some of you that are following closely our drivers probably noticed that we've got a Java driver 2.0 beta 2 currently, sorry. And it actually leverages a bunch of new features from Cassandra 2. So all the driver branch 1.0 target Cassandra 1.2, and the branch 2.0 target Cassandra 2.0. The reason for that is that we want to avoid the drivers to handle multiple versions of Cassandra, because that brings a lot of complexity. For instance, if you've got some of the nodes of your clusters that use Cassandra 1.2 and some of the other nodes that use Cassandra 2.0. So the natural upgrade path is for you to upgrade or to have a rolling upgrade of all of your nodes to Cassandra 2.0, and then to upgrade your driver to Cassandra 2.0, and obviously to leverage these brand new features. So one of the most interesting features from the driver perspective is that you've got this automatic paging. The idea is that it will allow you to iterate indefinitely, almost indefinitely, on a result set that can be terabytes of data, and without any issue on memory. You know, traditionally, if you're a Cassandra user, you know that you're not supposed to fetch gigabytes of data, because all this data will remain in memory both on the server side and on the client side. And with automatic paging, we solve this issue by making it possible to fetch only a chunk of the data. And the interesting thing is that here, all this is done in a fully stateless way. That is, at first, you will send the query to a node, and what you will receive is actually the first page, along with a state, which will be a bit like a cookie for your browsers. And these states can be reused in a second query in order to retrieve, obviously, the next page. But interestingly, even if the node you were talking to is now down, you can keep iterating over this very long result set, which is pretty cool, especially if this iteration had to be long. And with this very quick overview of the drivers, I will actually fall back to my great colleague Alex, which will present you this very brand new exciting product, and I really insist on that. We're really, really excited about it, which is DevCenter.
Thanks.
Yeah.
So today we are really, really excited to announce again the DevCenter 1.0. The guys back at our headquarters in San Francisco decided to push the PR announcement yesterday, probably because they are envious on us being on London and on you getting the chance to look at it first. But yeah, we prepared this for you especially. So what's DevCenter? DevCenter is a free visual query tool for writing SQL. And that's the long definition, but the way I would like to present DevCenter is that it's the smarter and friendlier brother of CQL-SH. And the reason I'm saying that it's smarter is that not only it supports a lot of features that CQL-SH doesn't, but we can extend it very far, and we have some very weird dreams about the future of this tool. So, with that being said, I was thinking what's the best way to introduce DevCenter to you. And initially I thought to try to pull a Steve Jobs, but unfortunately the turtlenecks sweaters are sold off, so I don't have that. And the other option would have been to brag about DevCenter with a bunch of slides. And I hate being booed, so basically I decided to go with a short demo. So we'll switch to demo mode. And it will take me a couple of seconds. I did some tests beforehand, so you should be able to see it from the back of the room. If you don't, please let me know. So this is DevCenter. It should feel familiar right away. In the left corner, we have some connection management that you can configure to connect to different clusters. Then you have a bunch of scripts that you can manage. And then we have a schema explorer and an outline of the current script. So what we'll do next is basically run a quick demo by creating a new key space, creating a new table, inserting some data, and bringing it back. Let's see if it works. So because my typing and speaking is not really my specialty, I would like to ask someone from the audience to start dictating me the create key space thing. So who wants to help me with that? I hope more people were familiar with SQL, really. I'm like, we've been pushing and working on it so hard.
So I think it's create key space. And then, oh, look at that. Wow.
Bam. I'm done. So I've already pulled this trick. So let's call this key space Cassandra Summit, right? And then we use Cassandra Summit to create the table. Let's say Cassandra users. And we have a user ID, first name, last name. Everyone has a last name, right? Yeah, we should adapt that model for. So because I already used the first trick, to the snippet, look at this second trick I want to show you. So because I used case-sensitive naming for the table, the DevCenter already notifies me that I shouldn't do that, except I want to use codes everywhere. So I'll switch that. I keep saving this file. I should probably save it. So let's do an insert next.
You can come with assist actually. You should.
Oh, don't play with my tricks. Right? And I can then duplicate this command a couple of times and so on and so forth. So just fill out new values. Or as Michaël said, I could use completion for that. And if you're paying attention to my typing speed, you'll notice that I get auto-completion suggestions for all these fields and table names, and they don't exist yet. Look at the key spaces. I don't have it. So we are bringing this information from the current script and augmented it with the real life. Who's the new user for Cassandra? I'll probably include myself here, right? So we have all these things, and then let's do a select to see if this actually works. I missed a comma?
Yeah, you're missing some commas. It's where you put some errors.
Oh, that's,
On the two first statements. Yeah. And here it's.
so while I wanted to tell you that I made these mistakes on purpose, that's not the case. But you could see, you could see how useful the tool it is. Like, you don't need to know SQL by heart. You don't need to run every statement to get validation. You get real-time validation of your script. And hopefully this works on my.
You haven't started your cluster.
That's a good idea. Maybe in the next version we should include that too. Yeah, I don't see anything on my very small screen. There you go. There it is. So this is DevCenter, and basically it supports running all your scripts, validating them in real time, and helping you with snippets and auto-completion for everything. And with that,
Let's browse the schema we've just created, actually.
yeah. So I have all the meta information here available. Partition key. I don't have a complicated key to show the clustering key and so on, but basically all this information is available through the IDE.
I have a question. Does the tool detect what kind of workflows you can do, considering the hierarchy definition?
Yes, it does. I don't have a complicated one here.
Suppose you would do like where first time equals something without defining a secondary index.
Let's try that. And it detects these cases for more complicated keys defined, and it also brings, most of the time, it will give you the right quick fix. Oh, please, other questions?
What about user-defined types?
So are you talking about the custom types or the user-defined type of Cassandra 2.1, which are obviously not supported because they are not developed yet, actually.
But we can support them.
So custom types are fairly particular indeed. So far, we've got nothing clever about custom types. So yeah, custom types are fairly exotic, I have to admit. So it wasn't part of our priority. So but yeah, we definitely want to support them because it's supported by Cassandra.
Come on over here.
Yeah.
I have two questions. The first one, the DevCenter support which version of CQL?
It's Cassandra 1.2 only for now. We obviously definitely want to support Cassandra 2.0 as soon as possible, and we'd like to provide you some smart stuff like telling you that these features is not supported in the version of Cassandra you're currently connected to, and so on. Which we believe is especially useful for a product that is moving as fast as Cassandra.
So basically, going forward, DevCenter will support all different versions to help you migrate from version to version. But the first one is only for 1.2.
Second one, is it possible to drill down the details column?
This one?
Can we see, for example, if we do an insert with the map, in the result you can drill down?
We'll support that. Unlike in the previous version, internal version, we had the details display here, but in some of the testing we did, we had some huge maps that.
Yeah.
So but we will definitely support that case.
We need to set up some nice UI, some convenient UI to make it feasible, and not just a long string. That's ridiculous. Yeah. So yeah, the question is, do we have a plugin version? Because the gentleman over there definitely realized that it was Eclipse based. So right now it's a standalone application because our priority is not to make it available just for Java developers, which are typically the Eclipse users, but to everybody. We definitely plan to have a plugin version, so you can expect it soon. I don't know if it will be in the next version or in the following one, but expect it. Yeah. Okay, go ahead. I will come back to you.
Same question. Are you going to do the IntelliJ plugin as well?
Yeah. So I think that will be the theoretical question. So the question is, we should have an IntelliJ plugin, and we'll see the feedback we get. It's obviously because the Eclipse, the Java world is yeah, it's separated between these two big worlds, and it's hard to please both of these two communities. That's something we can imagine having in the future. Obviously, it's we are talking about a much further future, but if you're an IntelliJ user, at least you've got a standalone application which...
A different way to think about it is we can go breadth first or depth first. Yeah. And we want basically initially to go depth first and then expand. Because this is the sort of tool that we need you to use to learn how to improve it. And once we keep pushing these things out. We'll start considering supporting different platforms.
Yeah, there were a
DevCenter.
question over there.
Yeah, is that are you planning anything like supporting prepared statement building in writing the code?
So the question is, do we plan to support prepare statement and extracting the code and all that? That's the kind of thing that we can definitely imagine doing, you know, bringing some helpers for that in the Eclipse plugin version, obviously with an integration with JDT, with the Java editor. As you can see, right now we don't support it. But yeah, that's in our project / dreams /
That's part of our
Yeah.
weird dreams about the
Yeah.
future.
Yeah.
Can you stop the code at line 14, for example, and see what happens? Just at that point.
Right now you cannot do that. Some guys internally, interestingly, proposed similar features, being able to maybe to do some step-by-step execution, you know, which can be very convenient because obviously if your script is getting very long, so you can imagine here probably having a big DDL script to initialize your production application or something like that, or maybe to upgrade your production application. That can be handy, and that's something I'm not sure yet. I don't know yet. We'll see what we can do with that and how we prioritize it, but that's some ideas we've got as well. Yeah.
So you mentioned that you have a look at the schema which is on the database and compare it with other statements that you've done, and then you give code complete based on the combined. Do you think you can like reuse some of that knowledge to make like a schema management tool for Cassandra? Because that's one thing we've been looking at recently with SQL.
Yeah, that's also part of our ideas. We'll see how we prioritize it, and that's interesting actually that there's so much ideas. Don't hesitate to come back to us with proposition and or to suggest or push features whether than otherwise. Whether than others. We don't pretend to know what has to be done. It's also depending on the feedbacks from everybody and the feedback from customers, but also from users.
I'm the product manager of these things, so getting feedback from you would be really helpful to decide what to do next. So
yeah.
You probably support comments in there, and basically you can probably paint something over and just run that one. I mean, you don't have to run the whole script every time.
right now in this version, you need to run the whole thing, but we'll support an interactive way soon, and then the debugging approach.
Yeah. Yeah. Excuse me. So that's a very good question that we haven't covered. What about this tool? How much do I need to pay for that? The good news is that it's free. Oh, okay. So the good news is that it's free. Right now it's closed source because we don't realize whether it's worthwhile to have an open source tool for something like this, for such an IDE. Here again, depending on the feedback that we get, if there's a huge demand for open sourcing it, which it's hard to predict actually, that's something that could be considered. Yeah. The question is, do we plan to have an object mapper? We got a bit late with that, but it's definitely in our plan. We don't have any ETA right now, but that's fairly high on our priority list. Yeah. Yeah. So that's part of the CQL language. You can alter the schema. Not any kind of alteration are possible right now. You can add some columns. You can change that type of a column, and and change. The third kind of alter that you can do on a table is to change the options of your table. You know, like the.
So one last
metadata.
question, because we need to empty
and
the room, and
please,
then we will be around.
Yeah,
so
don't hesitate to come to us to discuss about it. Yeah. So actually, that's very interesting. I don't know if Alex, you've got CQL nearby. No.
No.
Okay. So you can definitely use CQL besides it. And interestingly, this tool leverage the notifications that I've mentioned earlier. So if you drop a table in CQL you will see all the change being propagated to DevCenter immediately without any refresh. Oh, yeah, there's no import-export mode.
I have a couple more
feature yet.
keys with DevCenter, so.
Show us some magic